If you're a scientist, you know the feeling. Your project folder gets, well, messy. You've got scripts, data, different versions of your analysis, all constantly changing. Today, we're going to talk about a tool that can totally change that game for you, Git. It's all about turning that chaos into clean, reproducible science. So, let's jump in.
Here's the plan for today. We're going to start with the big question. Why is this even worth your time? Then, we'll get practical and walk through setting up your first project, getting the hang of the basic workflow, and finally, how to use Git to collaborate seamlessly with your team.
So let's tackle that first big question, the one every busy researcher is going to ask.
I mean, you've already got a million things to learn, right? So why add one more tool to your plate? What problem is Git actually solving for you in the lab that you can't solve with a folder full of files named Final, Final V2, and Final, I really mean it this time?
Think of Git as your ultimate safety net and your project's perfect lab notebook all rolled into one. We've all been there. A script that worked perfectly yesterday suddenly throws an error today. With Git, you can literally rewind your project to any previous snapshot when you know it was working. It prevents that nightmare scenario where something just stops working. More importantly, it creates a perfect, permanent history of every single change. This is the foundation of reproducible science, and, when a grad student or a postdoc moves on, the project's history doesn't walk out the door with them. It stays right there.
Okay, so maybe you're thinking, this sounds good, but is it going to be a huge pain to set up? The answer is no. Let's walk through how you can get your first solo project up and running in just a couple of minutes.
You've basically got two main ways to kick things off. If you've already got a project folder on your computer, you just navigate into that folder and type Git in it. That's it. It's like telling Git, hey, start tracking everything that happens in here. On the other hand, if you're jumping into a project that's already going on a server like GitHub, you'll use git clone to download a complete copy of it onto your machine so you can start working.
Okay, once you're set up, you'll find there's a really simple, kind of daily rhythm to using Git. Let's break down that core workflow you'll be using all the time. But before we get into the 3 steps, there's one key idea we got to get our heads around: the staging area. Think of it like a prep station in a kitchen. You don't just dump all your ingredients into the pot at once, right? You prep them, you group them. The staging area is just like that. It lets you bundle related changes together so you can create a really clean, meaningful snapshot or commit. So, that daily cycle? It really just boils down to these 3 simple steps. First, you check what you've changed with Git status. It's like asking, hey, what's new? Second, you use git add to move the specific changes you care about onto that staging area we just talked about. And finally, step 3, you use git commit to lock in that snapshot permanently, along with a little note about what you did. That's it. It's this simple loop. Check your status, add your changes, and commit them. Now, before you go adding stuff to the staging area, it is always a good idea to double-check your work. And for that, Git diff is your absolute best friend. It shows you line by painful line exactly what you've added and what you've deleted. It's the perfect last-minute check to catch a typo or a bug before it gets written into your project's history forever. And after you've made a few of those commits, how do you actually look back at all that history? Simple. Git log. This command basically turns your project into the world's most detailed searchable lab notebook. You can see every single snapshot, who made it, exactly when they made it, and the message they left behind. This isn't just a log, you guys. This is the official story of your project. It's what makes your work transparent and reproducible.
Okay, so you've totally got the solo workflow down. But let's be real, science is a team sport, right? To work with other people effectively, we need to talk about one of Git's absolute superpowers: branches.
So what on earth is a branch? The best way to think about it is like a parallel universe for your project. Your main, stable, this definitely works version of the project lives on a branch that's usually just called master. But when you want to try out a wild new idea for an analysis or fix a tricky bug, you create a new branch. This gives you a totally safe sandbox to play in, where there is zero risk of breaking the main project. It's freedom to experiment. And the workflow for this is super straightforward. You create a new branch, you switch over to it, then you just do your work. You edit files, you make commits, just like you normally would. Once you're happy with it and you're sure everything works, you just switch back to your main master branch and you merge your new work right in. It's a beautiful system for keeping the main project clean and stable. So branches give us a safe way to work on new stuff. But how do we actually share that work with our lab mates? Well, that's where remote repositories come in. And they're usually hosted on a platform like GitHub, which becomes the central meeting place for your whole team's project. Okay, this distinction is really important to get. The local repository, that's the copy of the project that lives on your computer. It's where you do all your day-to-day work. The remote repository, on the other hand, is the official version that lives on a server, like on GitHub. Think of it as the central source of truth that everyone on the team agrees on and syncs their work with.
And this all leads to the main rhythm of collaboration. You set up that central project on GitHub and add your teammates. Then, before you start working, you pull down any new changes they've made. After you've made your own commits locally, you push your work back up so everyone else can see it. It's just a cycle, pull and push. That's the heartbeat of collaboration in Git.
Yeah, this quote really nails it, doesn't it? The whole idea of collaborating with Git is just this constant cycle of pushing your work up for your team to see and pulling their work down into your own copy to stay up to date.
So as we're wrapping up, I really want you to think about this. What part of your own research, right now, could be made way more robust, way more reproducible, just by starting with that one simple command, git init? Think about that analysis script you've been tweaking, or that manuscript you're working on with a co-author. How could this change things for you? Hey, if this explainer helped you get a better handle on Git, do us a huge favor and hit that like button, share it with a colleague, and subscribe for more. It really helps us keep making these. Thanks so much for watching.